Hello, everyone. I'm Lucas Campos, here to introduce the Physics 2012 Lab 4 magnetic field of a bar magnet. And I'm going to preface by saying I'm outside, so it might be a little loud, so I apologize for that. All right, so the agenda today, we're going to go over the introduction and purpose of the lab, then move into the fundamental principles, along with the lab experiment, glow strip code, and then comparison, and then ending off with the discussion questions. Introduction. So the purpose of this lab is to find, measure, and understand the distances in which a bar magnet creates a magnetic field. So our system is going to be the magnometer and the phone, and the surroundings is the bar magnet and the earth. And then a preview is mu is calculated to be 3.51468, and this is after calculations done after the lab, which is a preview. And the models and fundamental physics principles is the Biot-Savart law and the magnetic field. So we have um, this law over here. It's going to be used a lot in the lab, and then these other magnetic field laws. Procedure. So first we're finding the sensor. So we align the phone with Earth's north-south axis. We place the meter stick and magnet orthogonal to the phone, and then we move the phone up and down until the X comp is at a max, and then we rotate the phone to see if the Y comp is max, and we place tape here so now this is like the axis in which we move it along. Procedure data collection. So the first thing we did was we moved the phone along the meter between the magnet and the manometer to measure the distance of B and the R. And then we repeated this two more times for 3 data points each. So see here we have the averages of doing all this. We found R and the B field. And next, the D perpendicular procedure. We moved the phone so that B equals 100 microtesla, and then we recorded D perp, and we recorded the Y comp, and we repeated to find averages. So again, same thing. We have the three things here, and then averages down here. Procedure D of 4 to 5 degrees. So you can see in this diagram here, we added a meter stick orthogonal to the first. We moved the phone up the D perp distance, and then we record the XYZ components of B, and then we adjusted Y comp by subtracting Earth's magnetic field. So you can see here, we have the D, the B, and then the B corrected after subtracting by the field, and then we have the X, Y, and Z. And we repeated this 3 times to find the averages down below. Moving into the glow strip code. So here we created the magnet at the origin. So this is actually already set for us. So mu of the magnetic is what we calculated for earlier. That's 3.51468. And this just, again, the mu mag times mu hat. And then here we have for the B, so we have this formula down here. And we created R mag, R hats, and the D products. Moving into the next part of the code, the distance is calculated to be 0.293. And then all the observation vectors is just, so the X components, Y components, Z components, all opposite of each other. And then we have 2 arrows here, and it's the observation axis minus the position, and we have 2 arrows. And then we have 4 arrows, R perp, and so this process was repeated for 4 arrows. And then for the 45-degree angle, we have the d perp is equal to 1.74. It's just calculated as in the last slide, and then d equals d perp square root 2. And then here we printed out the b and the b mag. So the results of this is we have b is this pretty small number, and then b mag is this small number. This the distances that those are found. And the data versus model comparisons. So on the axis, so for the first one, we have computationally calculated to be 2.794 e to the -5, and what we actually found was about 2.08 to the -5. So honestly, pretty close. That means it's working out good. And then in the 45, we have d equals 3.729 e to the -5, and here we have 4.43 e to the -5. So here it's a little bit of a difference. So obviously there's some things might have went wrong, and that moves us into the assumptions and possible errors. So in this whole experiment, we assumed that the phone manometer is just completely accurate because we just use an iPhone. But possible errors is, honestly, I'm going to start off with this bottom one. The app was horrible. We had so many issues. It just really wasn't working for us well, and it just kept causing errors and inaccurate data. And then nearby electronics creating other magnetic fields, and then human error in measurements. Finally, further questions. So what if we hadn't oriented and calculate calibrated in the beginning to be in line with Earth's field. That means it would work with the bar magnet, so X comp would increase. I mean, Earth, it would just have that much more of magnetic field presence on the object. And what if we stuck two ends of the magnet together? Ultimately, this would just be a combined magnet that's just stronger, and then the sensor would be calibrated further from just the one magnet. So everything would just be done in larger calculations and larger distances. And that wraps up the lab. Thank you.